Now I was curious if we could have left that fixed constraint on this line and everything would still work correctly. So I'm going to go back to that sketch and I'll edit that sketch, and I will put a fixed constraint on this line, and all of that sketch turns black, and it shows the lock symbol over here that it's fully defined. And then I'm going to drive this joint, and as I drive that joint, we see that doesn't break anything, that the sketch moves with the component, and so everything was fine with having that fully defined. Alright, so next we need to do that link pin that goes between those two components, and so I will make the link pin active, and I'm going to hide the other components for now, and we'll edit the sketch that we had started earlier. And we just verified that doing that fixed does not break anything, so I'm going to do fixed on this, and then I might need to do a fixed on one end or the other, and then I'll put in a slot. And so I'll do create a slot, and I'll do center to center, and so I'm going to click here, and I'll click here, and I'll come out, and then I'm going to dimension the width of this from here to here, 0.58, and that's fully defined. And I'm going to change this to construction, and I'll finish that sketch, and I'll extrude this, and we'll tell it to continue, and I'm going to extrude that. Now normally I would go mid-plane. For this particular part though, I'm going to go just in one direction, and I'll show you why in a second. I'll go 0.125, and we'll say OK to that. Now we could convert all of these parts to sheet metal, but only the ones that actually flatten out. There's no real need to create this or convert that to a sheet metal part. There may be some reasons to do that if we're doing a nesting routine to cut a bunch of sheet metal parts at once. But let's turn on the visibility of the other components, and we see that this component is placed in the center, or with one side of it at the center. I extruded in one direction, and so we actually need to move this out to this face, and I need to add a little bit of clearance to that as well. So I'm going to inspect the distance from this face to this face, and I see that that distance is 0.2. I want to allow a little bit of clearance, so I'm going to do 0.21 as the offset distance. So I go through and I'll find the joint between this plate and this component, and so I go through, and so that is the first joint, the second joint, the third joint up here, and the fourth joint that I put in up here. And I'm going to attempt to put an offset in here, so I'll say edit joint, and I'm going to, on this axis, I'm going to try to drag this out, and it gives me a warning that it can't do that. And the reason it can't do that is we have also a revolute joint on this end, and so a revolute joint only has 1 degree of freedom rotation. So in order to move this out, we need a cylindrical joint on one of these holes, either this one or this one, and then a revolute joint on the other. So I'll undo that. I'm in an error condition, so I'll undo that, and I'll go to joint number 3, and I'm going to edit that joint. And so instead of a revolute joint, I want a cylindrical joint. That will allow the part to translate and rotate. And then I'll go to the revolute joint, and I'll go to edit joint, and now I can drag this out, and I can put in an offset distance of 0.21. And so that time I don't get an error. So we have to pay attention to the degrees of freedom that we allow on our mechanism. So even though this component at this joint can translate back and forth, the revolute joint here keeps it from doing that translation. So mathematically it sees that as a joint that can translate, but physically, because of the revolute joint up here, it has that degree of freedom of translation, but it can't actually translate. It can only revolve at that location. I'll turn on the visibility of that press plate, and we'll drive this again. So I'll do drive joints, and so we see that those move. Now I need to put the same plate onto the other side. So I will go to mirror, and let's see if we could also just right click on this, and I don't see a mirror option there. That's too bad. I'll go to mirror, and I'll put it on component. I have that component selected, and I'll mirror that about the assembly XY plane, and that might be a decision I need to make because we might move this handle. And so let's do the XY plane of that handle. And so we see this component mirrored to the other side. Now if we try to drag this, though, we see that that component is not constrained to the rest of the components. It's not joined with joints, so we'll need to put the joints in on this side too. There might be a way to mirror those joints as well. I'm not sure if that's possible. If it is possible, put a comment in the comment section on how to mirror the joint as well. I'll do J for join, and I'm going to capture that position, and I'll select this circle on this side, and I'll select this circle on this side. I want to put in that 0.1 clearance. So I had a choice of doing this to the outside of this component or back to the inside. On this one I'm going to do it to the outside. I'll do 0.01 as my offset, and then I want to join the other end of this to this circle, and so I'll do joint. I'll capture that position, and I'll select this circle, and I'll select this circle, but I need to do that as a cylindrical joint or we'll get an error. So I'll do cylindrical so it can rotate and translate, and so everything is together. I test it out, and we see that our mechanism moves the way we would expect it to move. Let's go to the top level of the assembly, and I'm going to delete those two capture positions, and we'll put the pins in here, and then we'll create the plastic covers to go over the handle. For the pins, I'm going to do at the top level of the assembly and convert those to components. So let me hide the other components for now, and I'll go to the XY plane at the top level of the assembly, and I'll do a new sketch, and then I'm going to draw a circle, and I'll do this circle a diameter of 0.325, and I'll draw a second circle here, and I'll do that circle as 0.5. So if you remember the holes that we put into the components, we did as 0.332, so 7/1000ths larger than the cylinder that we'll use for this pin. I'm then going to extrude both the inside circle and the outside circle, and I'm going to go a symmetric distance, a total distance of 0.875. I'll make that sketch visible again, and so I need to go to my sketches, and I will make that sketch visible. I'll do extrude again, and I'll do a distance symmetric, total distance 0.675, and I'll have that cut material away. I'll hide that sketch, and then I'll do a chamfer or a fillet on this edge and on this edge of 0.15. Let's change that fillet to 0.1. So I'll edit that feature, and I'll change that from 0.15 to 0.1. I'm going to convert this body to a component, and so I'll tell it create components from body, and so I'll have that component down here. I'll rename this component, and I'm going to call this rivet dash long. I'll turn off that rivet for a moment, and then I'm going to make that sketch visible again, and I'm going to create a short rivet. So I will extrude both of these circles again, and this time I'm going to go symmetric, a total distance of 0.615, and I'll do the extrude again. I'll select this distance, and I'll go a symmetric, total distance of 0.4, and I'm trying to decide whether I want to add a little bit of clearance in between here or not. I'll go ahead and leave it on 0.4, and I'll say OK to that, and I'll do fillet again here and here, 0.1. I'll turn off the visibility of the sketch, and I'll convert this to a component, and so I'll tell it to create component from that body, and I'm going to rename that component as rivet short. So I'll name that as rivet-short. I'm going to hide this one, and I'll turn this one back on, and I'll turn the other components back on. And so I want this component to be up here, and so let's just drag it out here, and I'll do J for join. I'll capture that current position, and I'll get the center of this cylinder for my first pick, and then I want it halfway between this face and this face, or between this face and this face. So I'll select between two faces. I'll select this face and this face, and then I'll select this cylinder, and it'll put that rivet. Now I want that to not have any translation, I just want rotation, so I'll change that to a revolute. And so now I have that pin in place, and I need a copy of that over here. So I will right click on that long rivet, and I'll do copy, and I'll right click and I'll do paste, and we'll say OK to that. And I've got it now. Put it in the same location. It might be hard for me to move it. I was able to get it, and then I need to put this down here, so I'll do J for joint. I'll capture that current position, get the midpoint of that cylinder. I'll tell it for second selection, I'll say between two faces, and I'm trying to select the best face, and for this one I really would have preferred to select a component that doesn't move. So I'm going to select this face and this face, but I need to select a center point, and so that's not going to work. So let's remove those two, and I'll select halfway between this face, and that's not going to work because I can't get the second face on that, so I'll remove that one. And in order to get this between two faces that are part of this solution, I need to actually put it in this component. So I'll select that face, and I'll select this face, and then I can get this cylinder, and we put a revolute on that one, and I put it in the wrong place, so I need to put it up here. So let's undo that. I'm not sure which would be faster, to edit it or just undo it. Let's do J again. I'll select this. I'll tell it between two faces, between this face and this face, and then I need to make sure that I select the correct hole, this hole. So that moves that into position. I'll turn on the visibility of the short rivet, and I need to move this out of place temporarily so that I can constrain that. And so I'll do J for join, or joint, and I'll do capture position. I'll get the center point of this, and I want this between this face and this face, and I'll select this cylinder. I'll say OK to that. And then I need to make a copy of the short rivet, so I'll right click, I'll do copy, and I'll right click and I'll do paste, and we'll say OK to that. And let's move one of these out, get the short rivet. Okay. I move that one. I can turn the visibility of this one back on, and I'll do J for joint, capture that position, get this midpoint of that cylinder, and I will then do it And this one I could do either this part or this component. I'll do the mid-plane between this face and this face, and I'll select that cylinder, and it moves that one into position. I'll say OK to that. Test everything out. So I'll back out, I'll drag this down, and we could put a contact set in between here and here so that it doesn't go up here like it did. Or we could put a limits on that revolution joint on how far it can rotate, the number of degrees. I want to delete these temporary capture positions while I'm thinking about it. So I was examining my mechanism, and I went to the top view, and I saw that I have this rivet up against this face, and I need to make sure that it is not interfering with that face. And then I saw that I have some clearance over here on this side, so I have one of my joints is incorrect. And then revolution 5 back here, and so let's edit that number 5. I'll edit joint, and I put in 0.1, but I think I need to go negative 0.1, so let's go negative. And so now I see that I have the expected clearance that I intended between here and here. Okay, so now I have a clearance. So inspect your parts, make sure that you have the clearances that you intended. And so I'm going to come back down to here, and I want to measure that distance from here to here. So I'll go to the inspection, and I'll measure this distance from here to here, and I see that that is 0.67. And if I hide these components or measure the length of that pin, let's see if we can do an isolate. I don't know if there's an isolate in Fusion 360 or not. Find a rivet long, and I'll do isolate, and I'll measure that distance and see what that was between here and here. And that was 0.675, and I forgot what the dimension was from here to here, so we'll inspect that from here to here, and that's 0.67. So there is a 0.005 clearance between the plate and the end of this pin. And if I zoom in real close, I can see that slight amount of clearance. So design clearance into your components as you're modeling them. You don't want to get out to the assembly out on the shop floor and start putting things together and find out that they're too tight for the mechanism to actually function.